Okay, so today we're going to do a workshop on data cleaning, but before we get to that, I wanted to talk about just some general things that are important to know before you even start cleaning data set. And I should note for this video is really for the people who are not here, but then also potentially for people who join us in our lab in the future, so they can kind of get a rundown of this, and I don't have to be doing these every other day. Okay, so the main thing that I want to talk about is kind of a review of what theory is, what constructs are as informed by theory, what are variables and how they differ from constructs, and then a little bit more into some of the gist of this. So, you've heard this from many of your stats classes, methods, or even just your psychology courses where they always have that first chapter where they kind of go back through what theory is and what research is and what science is. So Borden's and Abbott is a methods book that I use when I taught methods at Florida International University. They define science as a set of methods used to collect information about phenomenon in a particular area of interest and build a reliable base of knowledge about them. I always think this definition is stupid and boring. So I go with Carl Sagan's definition, where science is a way of thinking. It's a way of approaching problems, defining them, seeking out information, and engaging in a testing of that information. Okay, and I like using this definition more because the more and more you get exposed to research and science as a whole, you'll start seeing that this becomes a way of thinking. And it's good and bad. Interpersonally, it can be bad, in part because you don't ever stop your job. Right, I've literally been walking with my wife, and the other day I saw a table for a group, an organization that was tabling at ODU in the Web Center about empowering women and stopping sexual violence, and it was something else that drew me to the table, and I just started asking questions about what they're working on and what they're doing. Oh, preventing racism, that was the top part. But all their projects are really on preventing interpersonal dating violence, which is definitely important. We need to address that. But I was like, okay, but how are you dealing with the top part? The starting point of your mission statement, right? And Cynthia just kept walking. She's like, I'm not going to wait for him. She just went back to her office, right? She's like, bye, I have stuff to do. And I'm like, okay, yeah, no worries. And I'm just there working, right? And again, it's a way of thinking. So you're constantly thinking of new phenomena, constantly thinking of new ways to do research, new things to study. Literally what just happened earlier in our meeting, right? Random conversation leads to a research study, right? Because science is a way in which you process the world, okay? So because the end part of the definition of science is testing, I'm going to talk about how we go about testing things, and that's the process of research. So research was established method that attempts to be as objective as possible and utilizes techniques that really test against your own beliefs, your own hypotheses. Now, I want to emphasize that although the goal of science, the goal of research, and the goal of the scientific method is to be as objective as possible, we are humans, okay? So it can never truly be objective. And if you have time or if you have the course load to take like a philosophy of science, they really get into some of the philosophical underpinnings of science and how beliefs about the world, about the nature of human nature, how all these things have shaped different theories, different views of knowledge itself, right? So like if you ever hear the word epistemology, all right, epistemology is the knowledge of where knowledge comes from, okay, the origin of knowledge. So in terms of the research process, we typically break it down to these 7 steps. The first is you observe some kind of phenomenon. More often than not in everyday research, when we say we observe a phenomenon, really that means we read an interesting article and we're like, oh, there's something missing here, right? Or we looked at their future directions, like, hey, look, there's a gap there, right? Rarely in research is you're walking down the street and you observe a phenomenon, all right? That actually doesn't happen very often. Okay, so when we use observe a phenomenon, we're using it very, very loosely in this context. Based on that phenomenon, you form some kind of tentative explanation. And there are two things that I want to say about the tentative explanations. That sometimes you actually may not necessarily have a tentative explanation. There are a few studies that are what we call atheoretical, in that they have no guiding theory. They're purely exploratory. Okay, so if you've heard of the Big Five, all right, when they came up with their theory of personality of Ocean, openness, conscientiousness, extroversion, agreeableness, neuroticism, they had no guiding theory. They were just like, let's see what happens. Okay, and that's okay, but it's really the minimal number of research studies that tend to have no theory guiding its research study. Okay, no tentative explanation. So this part of forming a tentative explanation is guided by theory. And I'll talk a little bit about theory and what that is in a few. All right, afterwards, you create a clear operational definition of your key variable. All right, I'll talk a little bit more about that. You will plan the appropriate study design. We will not be talking about that today. You'll further observe or experiment to rule out alternative explanations. You disseminate your findings, and then you go back and you refine and retest your explanation and then cycle back through. Which leads to what I often call in my courses the circle of science. Circle of life. I'll typically put like Simba here. Where you identify a question of interest, which may be something that you observe, maybe prior findings, whatever. You formulate an explanation based on a specific theory or theories, develop a hypothesis. You can specify a theory and not have a hypothesis. So there are some studies that are where you can't formulate an a priori hypothesis. So when it comes to American identity, for example, and it's linked to outcomes among veterans, there might not be enough studies to begin with to form an a priori hypothesis. And that necessarily isn't bad, right? Although reviewers tend to not like it. And then you carry out the research and you go through these steps. You communicate your findings and then you circle back. All right, so I mentioned theory, so let's talk about what theory is. Theory is something that we all strive to create, but very few of us actually do. Okay, and I want to emphasize that because a theory is not something small. A theory is, if you can make a theory, you have a book named after you, essentially, right? You're a chapter in a textbook. Okay, so theory is a set of related assumptions that allow for logical deductive reasoning in order to formulate testable hypotheses. Theories are large guiding frameworks, so they are typically a way in which we understand a series of phenomena. And the goal of a theory is to describe the observable phenomenon in reality, in your environment, using unobservable constructs. So I always use this as gravity, right? The theory of gravity. You can't see gravity. Gravity isn't a thing. Gravity is a construct. The word itself, construct, means something that's been created. And we call these things like gravity a construct because we have created this idea of gravity to help explain how reality works, right? So you don't ever see gravity, you see the effect of gravity, right? You don't ever measure gravity, you measure the effect of gravity, right? Just like self-esteem. Self-esteem is a construct. You don't see self-esteem. I can't take a ruler to your self-esteem, right? But you can see its effects. If self-esteem operates the way that we think based on our theory, then we would see a series of predictable behaviors, right? You'd be cheerful, right? If someone insults you, you'd be like, I don't care, right? You'd engage in certain behaviors that make sense based on our understanding of this construct of self-esteem, okay? So again, constructs are unobservable. The reality is what you actually observe. And the importance of a theory is that it makes doing and understanding reality much easier. Rather than creating a theory for why an apple falls, and a theory for why a pen falls, and a theory for why a laptop falls, you can just have the theory of gravity, right? It explains all of this. And it doesn't just explain why objects fall, it explains why we revolve around the sun, why the earth spins, why comets move the way they move. It explains a bunch of different phenomena, right? So this is a quick little video that I like to use. Hopefully it'll work. Oh well, nope. Alright, skip it, whatever. Oh wait, there's a play button. Nope. Nope. All right, whatever. Skip video. I'll send it to you. All right, so theories are typically composed of many parts that range from the unobservable to the observable. At the top of a theory are the axioms or postulates. These are things of a theory that do not go tested. Okay, so these are assumptions that we make about reality or the nature of human nature, and we don't question them, we just kind of take them and go. So every single theory of science makes an automatic assumption that there is such a thing as reality, right? We're not in the Matrix. Right? Every theory of science makes that assumption. There's no way you can prove that. You can't prove that all of you are not figments of my imagination, right? That's the realm of philosophy. Right? But because we can't prove that, because we can't support that through scientific inquiry or through scientific methods, we make it as an axiom, as a postulate, something that we will never test because it's impossible to test, right? And we kind of move on. But other theories make other assumptions, and sometimes they don't test these assumptions, right? So like Freud makes the assumption that we have an unconscious, and he doesn't really test it necessarily very well, although he kind of tests parts of it, right? So understanding axioms and postulates of whatever theory you're using is important because it's going to inform what research questions come out, what constructs are used, the importance of the constructs in relative to the theory, right? So if you have a theory of psychology or sociology, they're probably going to, for the most part, not pay too much attention to biology or physiology, right? Because immediately an axiom or a postulate of the theory is that sociological and psychological processes have greater weight. Okay? So it's important for you to understand the underlying postulates of a specific theoretical framework. Now, within a theory, you have hypothetical constructs. They're called hypothetical because, again, you can never prove anything in science. All you can do is support. So you should eliminate the word prove. You should never see prove in any writing. We do not prove, we support. Okay? You can't prove because you can't prove the null hypothesis. Okay? So there's no proof, there's just support. So all constructs, even gravity, are hypothetical constructs. Now gravity has been very, very well established, and that's great for gravity, but it's still a hypothetical construct. If aliens came in and it's like, oh, this gravity thing that you've come up with, totally wrong, right? And they explained the right way, we'd be like, oh, well, I guess gravity was stupid. Here's the new theory, right? Because it's all of what works best to explain reality, okay? And there may be a better explanation that we just haven't figured out, right? And I keep making fun of gravity, and one of the reasons I do is because we still do not know how gravity relates to all the other forces in like the physical world. Gravity is the outlier, right? So, which is why an alien could theoretically come and be like, oh no, you've been understanding this totally wrong. Anyway, so theories may have one construct, or it may have 1,000 constructs, okay? Each theory is going to vary as to how many constructs it has, and constructs are typically what you're going to be focusing on, right? The theory doesn't just postulate a construct, it also postulates a relationship between the construct and the observable. So self-esteem is a construct. Identity is a construct. Ethnic racial identity is a construct, right? Well-being is a construct. Alcoholism is a construct. All of these things are constructs. They're ideas that embody a set of observable patterns. Okay? Now, from the hypothetical construct, you might make a specific hypothesis. And in a hypothesis, what you're doing is, based on our understanding of this hypothetical construct, we hypothesize that it's going to relate to X, Y, and Z, or it's going to affect so and so and so. And really what you're doing with hypothesis and with research is verifying that the construct relates to the observable aspects of reality, okay? Because if the construct doesn't relate to reality or observable phenomenon the way it's supposed to, then obviously your construct sucks, or your understanding of the construct sucks, right? So it has to be revised. Hypothesis has been supported over and over and over will be known as a fact. A fact that's been supported over and over and over will be known as a law. But a law can be undone, okay, by just a new way of thinking or research that contradicts it, right? Very unlikely to happen, but it can. So the law of thermodynamics could be undone. The law of gravity could be undone. In psychology, we only have like a handful of laws, so you don't have to worry too much about that, all right? And they're not in any of the areas that we study, All right. So scientists relies on theories and hypotheses for many reasons. Theories and hypotheses permits us to place information, observations that we make within reality into some kind of coherent framework. It helps explain basically findings, why things are related the way they seem to be related. It helps us make new predictions about behavior in the future. And when we think about this from a practical standpoint, the goal of science is to help, to provide a betterment to society. So we want to be able to make predictions about things in the future, right? And again, it develops new ideas for future research. Okay, so now that I talked about theory, again, a theory has several, or may have one hypothetical construct, or it may have several hypothetical constructs. But a construct is just an idea. A construct doesn't tell you how to measure it. That's where we get to variables. Now, one hypothetical construct can be measured in an infinite number of different ways, and I'll get a little bit into that, okay? A variable is the way that you have selected to measure this specific hypothetical construct, okay? A variable is typically the focus of scientific inquiry. So any study that you do, really what you're doing is looking at how variables relate to each other, okay? Keeping in mind that those variables are proxies for some kind of hypothetical construct. So we're not really measuring ethnic racial identity, we're measuring this scale, this measure that we hope taps into ethnic racial identity. Our variables are how people responded to this questionnaire. Our construct is ethnic racial identity. And we hope that there's correspondence between that, right? Which is not always the case, which is why you have so many different measures of discrimination, so many different measures of ethnic identity, everyone's coming up with their own measure because no measure is ever perfect, okay? Now, variables are called variables because, by definition, they vary. You're all like, whoa, what is this like, right? So variables will vary across people. They can vary across time, so you yourself may respond differently over time. Or they can vary by context, but they have to vary. If you have a variable with no variance, everyone responds exactly the same way, you cannot study it. It's impossible. Literally, all your models, all your statistical procedures will say no. Because what are you going to explore? The difference between why person 1 put 1 and the other person put 1 and the other person put 1, nothing's going to make an impact on that, right? So variability is essential for science, for understanding things, all right? If there was no variability, we wouldn't care, okay? There are an infinite number of variables. Any one study may focus on one variable or may focus on 20 variables, all right? It really depends on the goal of that study and the underlying research question as it relates back to theory. So let's talk a little bit about what we mean by variability. There are different types of variables, so we're going to go over the different types, okay? So nominal is the first type of variable. A nominal variable is basically a label. It's something that has no order, no quantitative difference, and no absolute zero. So for example, gender. Gender would fall under a nominal variable. Because although we may argue, if we want, about whether males or females are better than each other, at the scientific level, there are no differences. These are just labels, right? Ethnicity and race would be a nominal variable, okay? So anything that's just a label and there's no meaning as to whether one's better than the other, that is going to be a nominal variable, okay? Occupation could be a nominal variable. It could also not be, depending on how you assess it, okay? Ordinal variables are variables that do have an order. So there is a smaller and there is a larger, okay? Or a faster or slower, however the dimension you're measuring is, okay? But the difference between points is unknown. So the example that I always use to explain this is racing, right? When you race, there's a second of how long it took you to finish the race. But that's often not reported. What's reported is whether you came in first, second, or third, right?
if you're in a race and you came in second place, right? You might be like, oh damn, I didn't win. I didn't go in first place. But your time difference might have been 1 second from the person who came in first, right? Versus if you're in another race and you came in, second place, but your time difference was 10 minutes, right? Which one are you gonna feel better about? The first one, right? Because you almost did it, right? So in ordinal data, you know that first place is better than second place, and that's better than third place. But the difference between them isn't captured, okay? Examples for the research that we do include a letter grade. So if I ask you whether you get A, B, C, or D, there's no exact difference between an A and a B, right? Because you could have had a 4.01, right? Right at the edge of A. And this other person could have had a 3.99, right? In which case, that person gets a B, and another person who was at what's the lower end of B? I don't know grades, which is horrible. I know percentages. Okay, I'm gonna use percentages. 90.1 versus an 89.9.
Oh.
One would be A, one would be B, right? But the B person gets clumped with the person who got an 80.1, right? So all the B's are not the same and all the A's are not the same. But there's an order. Clearly the A did better than the B. But there's an A that got 100%. That A did much better than the other B, right? Than the other A. So if you use letter grade, A, B, C, D, F, that's an ordinal variable. If you were to use percentage though, like your actual grade, the percentage, that would make it an interval. And I'll talk about that, right? Educational attainment, right? We will often ask people, do you have a high school degree? Do you have, did you start college? Do you have a college degree? Do you have a professional degree or whatever, right? If we ask it that way, that makes it ordinal. Because again, someone may have done some college, but some college might be 1 year, some college might be 3 years, right? Someone may have a professional degree or a graduate degree, but a master's and a PhD are somewhat different from each other. A PhD and an MD are different from each other, right? All have different expectations and requirements. So grouping them together is not also necessarily putting the correct order. But we ask about years in education. How many years have you been in education, right? Starting from like 5th grade. That would be more interval. You would know exactly, right? All right, and then hotness scale. Not in terms of beauty, in terms of food. Like peppers. You might be like, oh my God, ghost peppers. That is like a 20, right? Or whatever, out of like 10. So yeah, so that might be another example, okay? Interval data. Data with clear order, so you know what's smaller and you know what's larger, and the difference between each value is known, okay? So temperature, for example, is a good example, right? So you know that higher temperature is hotter and lower temperature is colder, right? You know that the difference between 83 degrees and 84 degrees is 1. That's measurable, right? You know exactly what that means, and that difference is the same as the difference between 92 and 93 degrees. Now, how you perceive heat, that would probably be more ordinal, right? Because not everyone perceives heat the same way. And sometimes going from 93 to 94, who cares? At this point, you're dying, right? Versus going from like 80, like from 72 to 70, you're like, me. You all might be like, oh my God, this is death, right? So again, I mention this because constructs, the hypothetical construct, can be measured in any type of way, right? It's how we decide to measure, the decisions we make prior to the study even being done that are going to determine where it falls on this range, okay? So another example is year and date, right? Okay, so I have a question. It actually kind of sucks that Julie left for this part, so hopefully she'll catch this because this brings up a conversation that we had the other day. Are Likert scales, are these ordinal or interval?
Ordinal, yeah.
Okay, so we have 3 ordinals.
I feel like I have to say ordinal now.
Yeah. You don't have to say anything.
Okay, you can just
I
stay
support
impartial.
her in
I
not
feel
saying
like-
anything.
It could be both, right?
Okay. So let's see. So this is a response from a study that we have. The measure here is, I am clear about what my ethnicity means to me, and this is the one item that we're looking at. And here's the response rate, right? So we have 50%, 57% of people said it does not describe me at all, 168 describes me a little, 302 describes me well, 408 describes me very well. So based on this, what do you think? Does it look ordinal or does it look interval? Ordinal? Okay. Now this is what happens when you average across items. So this measure here has, I think, 10 items, okay? And if you take the average, you're on camera. Okay. So if you get these 10 items and you take the average across them, this is what this distribution looks like. So does that look interval or ordinal?
That looks interval.
I feel like it's interval because there's a clear, like, number scale on each side, and we know definitively numbers where they fall on that.
Yeah. And this is why we ask more than one item.
Yeah.
So all the skills that we work with in our lab isn't just like, do you know what your ethnicity means to you? And that's it. Right? Because if we did that, that would make that data ordinal. But when we ask multiple items that capture the same construct or variable,
I don't want to be on camera.
I'm saying that you are. Okay. When you ask multiple questions that capture the same construct, you then get this interval distribution, right? And this is very important. Measures that have more items are going to work better because they're going to be more likely to capture individual differences in this, okay? All right, and then the last group of variable is called the ratio variable. Every variable that is ratio is interval. Not every variable that is interval is ratio. Ratio data is a variable that has some kind of 0 point. Okay? So age has a 0, conception, right? If we were to use Kelvin, then temperature would have a 0 point, where it's the absence of movement. So it has to be something that's clear. Now, if you use Celsius or Fahrenheit, it is not ratio, because Celsius and Fahrenheit, although they have a 0, they have negative numbers, and that destroys the concept of 0. Okay, so ratios are anything that have an absolute 0. Weight, right? You can have a weight of 0. I don't know what that looks like, but it's possible, right? It's the absence of mass, essentially. Height, you can be nothing, right? Age, you can be no age, right? You can have just been born, right? So these are technically ratios in the most technical sense, although they won't look it in terms of its distribution, okay? All right, defining variability. Now, it's important that we talk about the distinction between nominal, ordinal, interval, and ratio, because how you capture variability in these variables depends on what it is, okay? So if you're dealing with interval or ratio, you can perform several series of measures of variability. You can calculate the mean, which is the average numbers, where you add all measures up together and you divide it, and that gives you the average response to that. You can calculate the median. The median is the middle value in all the numbers that you have when they're organized from lowest to highest, right? You can calculate the mode, which is the most commonly seen response. And you can calculate standard deviation, which is essentially how much do people vary from the mean. All right, and by calculating standard deviation, you can get a measure of dispersion, how far people are spread out, okay? Variance is also a measure of dispersion. Variance and standard deviation are basically the same thing, except standard deviation is the square root of variance. So they measure the same thing, okay? Now you can't do this for ordinal data. For ordinal data, you theoretically cannot calculate a mean because there's no set interval between them, okay? For ordinal data, all you can do is the median, and even then, probably not, and the mode, which is the response that was most provided. And then for nominal data, all you can do is the mode. And even the mode is going to be odd, because the mode has to be kind of qualitatively coded, right, depending on the response. But you can look at, how many males you have versus female, right? When you look at that percentage breakdown, essentially what you're calculating is the mode, okay? I should have done a printout of this, huh?
Yes.
Whoops. It'll be available on TARDIS thingamabobber. Okay. So because constructs are ideas and measured by specific variables, when we are thinking of what variables we're going to use to measure the construct, we have to get into the process that's called creating an operational definition. The measure section in every paper is essentially the list of the operational definitions that are given by the authors towards measuring the constructs. So an operational definition is a statement that clearly and carefully describes the variable being studied, as well as the procedures and instruments used to record observations. The goal of these measures are to be as objective as possible, but keeping in mind that every measure has a certain margin of error, and that's okay. We have to just keep that in mind, that some measures may have more error than others, but all measures still have error in it, even physiological measures. All right, so scientific measure, because again, this is a construct, you can use an infinite number of variables to measure the same exact construct, okay? So any one idea can be operationally defined in a number of ways. So here's an example that I stole from Dr. Judah in his lab, social anxiety. Social anxiety may be measured by heart rate, right? You can put a monitor of their heart and have them talk with a bunch of people in a classroom, right? And you can see that the people who have social anxiety, right, would exhibit much faster heartbeats, right? The idea being that social anxiety causes activation of our sympathetic nervous system and thus puts us on alert, right? Or you can just do it by behavioral responses. You might put people in a room, like a party, and then just mark whether they're engaging in avoidant behavior, whether they're going to the corner and getting away from people, right? Looking away, whether they fail to make eye contact, right? And you might just take a note of it. Yes, no eye contact. Once, twice, 3 times, and just literally track the behavior, right? Or you can ask a questionnaire, right? And in a questionnaire, you would be like, okay, well, how stressed out do you get in social interactions? And you have them respond on some kind of Likert scale or question or response scale, right? So each measure has to be evaluated for its reliability and validity. Reliability is the level of consistency of a response to assessment device while assessment. So essentially, reliability is how often the measure produces the same exact result. So if you get on your scale at home and you get on it and it gives you one weight, you get off it, and then you get on it and it gives you a completely different weight, there's no way you lost that much weight or gained that much weight within a few minutes, right? So that scale is probably not very reliable, okay? Validity is whether the assessment is measuring what's intended to measure, right? So even if the scale, so let's say the scale, you get on it and it gives you the same exact weight over and over and over. But that scale is set up where it gives you a weight that's 20 pounds higher. That measure would be reliable, but it wouldn't really be valid, right? Because it's not really measuring weight. It's measuring weight plus 20, right? So reliability is a requirement for validity, but just because a measure is reliable does not make it valid, okay? And the way that I use it is this chart of darts, right? So a measure that's reliable but not valid is like if you were to throw darts at a dartboard, you circle up, but nowhere near the bullseye, right? This measure has low validity and low reliability. You're all over the place, but nowhere near the bullseye. And this measure is not reliable, not valid at all, okay? So you're definitely not even near the bullseye. You're just somewhere around here, and you're not consistent either. And then this measure would be reliable and valid, right? Consistently near the bullseye, and that's where you want to be, okay? Alright, so I mentioned the different types of assessments, so let's go into the common types that are used in our lab. Really common type, and then I'll talk about some that we may be using in the future. So we mainly rely on self-report or other report. Other report is when someone else reports about someone else. So when we do like studies, which hopefully we'll do, with parents, we'll have parents report on their children, and we'll have their children report on the parents. Okay, so in that context, that's other report. But either way, it's an assessment, right? They are responding based on their own behavior, on their feelings or thoughts, or the behavior, feelings, and thoughts of someone else. This is often done with a multiple choice questionnaire, typically with a Likert scale, but it can also be done with open-ended questions. And whether you decide to do it open-ended or multiple choice is going to determine whether the data is nominal, ordinal, or interval, right? So again, prior to coming up with your study, you have to think about that because that's going to have implications for how you analyze the data. The limitations of self-report is that it's not always appropriate, so you can't really have an infant rate how well their parents do, right? Yes, people with certain disabilities may also not be able to respond very well to self-report. Some people may not necessarily be literate, so if you're giving them just a paper and having them fill it out, they may not be able to read, okay? Yes?
Wouldn't self-reporting there would also be some sort of bias, like you're biased towards yourself, and
Yep.
then also if you don't have the discipline to like, if you have to do like a self-report for 2 weeks, and you miss a day, and then you miss another day, like there's no like set framework?
Yeah, so the missing day stuff would be not always appropriate. Some
Okay,
people,
right.
for example, people who have ADHD may have difficulty doing a 1 hour session.
Right.
So in that case, your survey is not very appropriate.
Right.
And then what you're talking about, the biases, that's what we call social desirability. So essentially, we tend to respond in ways that makes us more desirable
That
to
look
other
better,
people.
right.
To make ourselves look better, right? Now that can go either way. That can be like, oh yeah, I never use alcohol or marijuana. How dare you? Versus in certain contexts, if you think the more desirable response is like, man, I got so high the other day. Please do not take this out of context, right? Because I mean, when I worked with the alternative high schools, I had kids that I would see in the recordings, particularly when they were talking with female interviewers, that would play up like certain behaviors, like yeah, man, you know, like I went into the club. Yeah, things like that, right? It feels better, yeah.
Yeah.
So like that can go either way. It can heighten or suppress behaviors, but you're right.
Right.
Social desirability is a factor. This is one of the reasons why we tend to have nowadays self-report more often than not be done on computers, because there is no other person there. No one's looking at your data. So even like when we go into the schools, we'll look like when we were grant funded and we would do some of this stuff, we would go into schools and literally like in a table like this, tablet, space, tablet, space, tablet, space, tablet. All the tablets would be connected to the power, and we would just sit them down, show them how to work the system, get them acquainted with it, and then they would just do the study. Okay, and we would only interact if they had a question, and depending on the question, we might not be able to give any guidance or advice either, right? So that helps to mitigate social desirability, but it's always gonna be a confound, right? And we talked about the issue of like undocumented status, right? If you're asked certain questions, you may just not want to respond because even though they tell you that no one's gonna see your data, you may just have a certain distrust about that, right? And so the data may be biased because people who are distrustful may be responding in a way that's different from people who are more trusting. And this makes research and self-report, that's a limitation of it, but it is what it is, right? Every method is going to have its own limitation. Item wording. So how you phrase items can have implications for what the item is actually measuring, right? So for example, it was only in the 2000s that we realized that being happy and being depressed are not mutually exclusive sometimes. Just because you're not depressed doesn't make you happy, right? Now typically if you're depressed, it's unlikely for you to be happy, unless you have like bipolar and you're going back and forth or something. But just because you're not depressed doesn't mean you're happy either, right? We realize that happiness is its own thing, okay? And that was important because in some measures of depression, you would find items that are negatively worded, right? Like, I'm very happy today. Well, are you measuring depression on that item? Or even if you reverse code it, or are you just measuring the absence of happiness, right? that item is going to have a negative impact on the validity of the construct, the measure, right? Now, self-report work because of a very fundamental understanding of observable and unobservable. Unobservable and observable. The idea is, for example, in depression, if you are high in depression, then you're going to behave in X, Y, and Z ways. So when you are presented with a questionnaire, your response on that questionnaire is a reflection of your level of depression. Your level of depression causes you to respond this way. So if you ever get to a part where we start working on projects, and maybe we might do a psychometric project where we evaluate whether a measure is working the way it works or anything like that, this is what is considered a traditional measurement model, right? Here is the unobserved construct, the latent variable. That's what it's called in statistical terms. And here are the actual questions that we asked. And if you notice, the arrows go from the construct to the question. And the reason is because this construct causes us to respond 5 on strongly agree, right? Or 2 on disagree, right? The construct drives the response. All right, I'm going to briefly go through these two. So behavioral assessments are specific behaviors in a specific situation are evaluated. Limits what you can ask in behavioral assessments. These are, we may be using some behavioral assessments, actually not, we are, because the implicit association test is a behavioral assessment. And we'll be using that with Julie's master's thesis and potentially a few other projects. If the parenting grant gets funded, we'll be doing clinical interviews. And I should note, if that grant gets funded, we have 4 spots that will be paid. I think $8,000 a year. Don't get your hopes up. It's probably going to get funded by the time you're all out. These things take a long time. But if we get lucky and we get funded on the first go, there'll be paid positions. And the ideal is probably we'll have 2 from our lab and 2 from Dr. Paulson's lab. Okay? But those RAs, what they'll be doing is clinical interviews. Okay? Structured interviews where you ask participants a series of questions to try to diagnose them essentially with depression. Okay? Limitations of these is that they tend to be somewhat subjective. They have to be done in person, so as a result, they do open themselves up to social desirability. The interpretation of them can sometimes be subjective, although the one that we're going to be using is not subjective at all. It's a fairly objective measure. And then the reliability and validity of it is kind of hit or miss, depending on what measure you're utilizing, depending on what clinical interview. Okay. Physiological instruments may be something that we'll be using in the future, in part with ECs and our collaboration with Dr. Judas and the ERP lab. So this can include MRIs, heart rate, behavior, blood alcohol level, if we're to do alcohol stuff, and eye tracking. So EEG is also the physiological measure we're going to be using for that collaboration. These measures tend to be more objective, but whenever you start dealing with physiological measures, the big issue becomes, well, how does this translate to psychological processes, right? Just because your heart's elevated, does that really mean you're more stressful? Does that really mean you're panicking? Or is it because you saw someone that you're attracted to, right? That's where the self-report can shed light on the context, right? Like if I was in Dr. Judas' lab, and I noticed this like the moment I walked in, my ERP levels would be a little bit higher if I got into the Ravenclaw room, right? Because he has a little tiny button on each room for all 4 houses. And the fact is I would never be able to be in the Ravenclaw room because the Ravenclaw room is one of the computer centers, and that would bum me up because I'm a Ravenclaw, right? And I got in there, I'm like, oh my God, you have the houses. That was the first thing I noticed. Okay, he's like, yeah, we have them there so that we know which room is which. And I'm like, oh, but you should get the big banner. He's like, no, we're trying to be innocuous so that people don't notice them. And I'm like, I failed. I noticed them right away. To the point that if I was a participant, I'd be like, can I go in the Ravenclaw room? Right? So again, whether my responses would be accurate or not, we don't know because you're not really sure what that corresponds to sometime, right? And some of these measures are validated through self-report, right? So the idea here is that it's not that these measures are better than others, is that they're a different type of measure. And this is important why research should be more and more interdisciplinary to use different types of measures to try to get at the construct. Because that's what all of us are interested in, measuring the construct. Some of us may measure it through qualitative, open-ended interviews. Some of us may measure it through Likert scales, others through physiological instruments, but we're all trying to measure the same idea, right? We're just using different tools. Each tool has its own perk. Each tool has its own con, okay? All right, so that's it for that part, and I thought that was important to cover because what you're really going to be learning today in the next 30 minutes, which shouldn't take too long, is coding. SPSS syntax cleaning. So SPSS has two ways to work SPSS. The first way you can work with SPSS, and this is the way that most people tend to work with SPSS, is point and click. So SPSS has a lot of commands that literally, you can just point and click. Well, I don't have any data. Actually, their license is expired, so this is why this looks all red. Normally, this would be in colors, okay? And red, if you see red on syntax file, that means you did something wrong. In this case, the wrong thing is that they haven't renewed their subscription for this particular computer, okay? Because there is nothing wrong with this syntax file. But anyway, so in SPSS, you have to point and click, and that's typically the easiest way. So if you want to do a correlation analysis, you open up your data set, you go to analysis, you go to correlation, and you just run correlation, you throw in your two variables, and bloop, you get a correlation, right? The other way to run SPSS is through what's called syntax files, okay? Syntax files are like the coding for SPSS. Everything you can do with point and click, you can do with a syntax file. In fact, actually, when you go and do the point and click process, there's a little button that says paste. If you click that button, it will paste the specific command that you're doing into a syntax file, okay? So why do we use syntax files for cleaning? Two reasons. A, if we ever need to use this measure again, we can just copy paste the cleaning syntax and just change it a little, right? B, it's a way to verify that everything you've done is actually accurate, okay? So because when you're creating a syntax file, you're not actually working with the data itself, I'm the one who runs the syntax. I can go through the work and make sure that, okay, yes, all these items do correspond to this. And then on projects where we collaborate with other colleagues, this is particularly important because they want to make sure that you all did your job correctly. And I can just be like, syntax file. Here, go through it, check. I already did, but if you're really, really concerned that we coded something wrong, do it yourself. This is what we did, right? So this is one of the reasons why I like using syntax file. Actually, this came up in a conversation yesterday in a meeting with one of our collaboration projects. I told them, I'm like, oh yeah, I have a team of undergrads who are gonna get trained in how to do this, and they're gonna be working on this. And they're like, can we trust undergrads? And I'm like, well, I need to explain to you how I do data cleaning. I have them create data syntax files. They send it to me, I review, give them feedback so they learn, and then on top of that, I'm the one that runs the syntax file, and then I do the final cleaning. And they're like, oh, okay. And they were very comfortable with that process, again, because there's a system put in place. And then this also gives you valuable information about how to clean data, but also how to write SPSS syntax. So this is something you can include on your CV, under skills, because not many students get taught this, right? Some doctoral students don't get taught this, okay? So we're gonna cover the syntax that SPSS has specifically to cleaning. I printed this out, and this is the part that I actually thought you needed the most, because the PowerPoint is cool and all, but I mean, you're gonna be working on this, right? So I gave you several examples of the key commands that you might use. So, and I gave it for demographics, I gave it for 2 different measures, and then I gave it for an outcome variable of alcohol use that has its own distinct style, right? So for the demographics, you'll sometimes have to delete variables, and the delete command is very easy. It's just delete variables, and it doesn't have to be capitalized. I just capitalize them just because it makes it stand out more, but it doesn't have to be capitalized. And then here you see .stat version, .stat, all that stuff. These are just stupid variables that our survey system pump out. Qualtrics does the same thing, and you're gonna want to delete some of those stupid variables that we don't need, right? So Qualtrics has response geographic location, which if we're not using, shouldn't probably, we need to delete that variable. So you would just write a syntax file that says delete X, Y, and Z, right? And then execute is what SPSS likes to see in order to actually do it. If there is no execute, SPSS is just like, all right, cool, it's loaded. When do you want me to do it? So you actually have to say, okay, this is what I want you to do. SPSS is like, okay, I'm ready. And then execute. So you should always put execute on top of almost every command. Okay, and you'll see that throughout this. Okay. The next command that you'll see is rename variables. Okay. So in the rename variables, you put parentheses, the current name of the variable equals the new name of the variable. Okay. So in this case, this is a longitudinal data set that we're looking at right now. So the underscore, this is how I note time. Okay. So if I'm working with a longitudinal data set, underscore 1 means time 1. Underscore 2 means time 2. Right now, we are not going to be coding any longitudinal data set. So when you create this, you would just say gender. Okay? Underscores in my lab are only used when we're working with longitudinal data sets, and I would let you know if we're working with a longitudinal data set. For the loss of face, if you are going to be working with Julie, that is a longitudinal data set. So you would want to use either underscore, or if she has a different system, she will let you know about that, right? But for me, when it's my data, my project, it's underscore, okay? So here, basically, the way that our survey system for this study did it was DEM001 was just the first question, DEM002 is the second question. So we're basically renaming them so we know what the hell DEM001 means, right? And then here is a variable label. So if you ever pull up the variable view in SPSS, you'll have the variable name, and then you have a label. The label is what gives you the information about what that variable actually is. So you want the variable label to be as informative as possible. So here, the process to do this is you put the variable name, and then in, that's actually wrong, it's not quotation marks, it's, I think it can be either one. It can either be quotation marks or just the little one, the one. Not the one that has two, but the one that has one.
Oh.
Yeah. Right. I'm pretty sure you can apply either way. But whatever, we can check that. So here, the way that we did it in this lab, in this project was we would just actually put the item wording here. So you'll see what is your gender. And this is very useful to actually have the specific wording because it lets us know exactly what was asked, right? So for example, that's why we call it gender and not sex, because the way that the people who made the study asked it was gender. So they're actually not reporting physiological sex, they're reporting gender, whatever that may mean to them, right? Although we only gave them male and female, which is, you know, whatever, not my decision. All right, age, same thing, how old are you, birth loc. So typically SPSS does not like really long variable names. We want to try to keep them to about 8 characters. So we have to condense something. So birth loc, if you saw that in a data set, you're like, well, what does that mean? Well, that's where the variable label comes in. It's where were you born? And essentially this question is, were you born in the United States or not? That's your first 2 options. And then they have other options if they say no, okay? All right, recode. So the way we coded age, or the way we asked age in this data set, because this was with adolescents, is the lowest age we gave them the option for was 11. And then it went from 11 to 18 because it was a longitudinal data that was going to go for 3 years. And we had 10th graders. So it was possible that some 10th graders after 3 years would be 18, right? So we don't want it as 1 because 1 was what, 11, right? 2 was 12 and so on. That's useless for us because no one's age 1, right? If we were to analyze that, we were to calculate the mean, it would tell us like the mean age is like 5 or point something. When like that's not informative to us, right? So recode, you are able to create a new variable and change the response patterns, okay? Recode can be used for something like this, demographics, but if you ever have a reverse coded item, a negatively worded item, you have to use recode. And we'll see an example of that in the ethnic identity scale, okay? And negatively worded items are items that are worded in the opposite direction as all the other items, right? It's not necessarily that they're negative, like they're sad or bad or whatever. It's just in the opposite direction. So in a measure of depression, a negatively worded item or reverse worded item would be a measure that captures happiness, right? Because you're trying to measure depression, not happiness. So you would have to reverse code that item. so that all items are in the same direction, essentially. Okay. So the way you do this is you specify the current value and what you want it to equal, and you keep doing it, and so on and so on. All right. Now in recode, there are two types of recode. There's recode where you recode the data into its own variable. So you're not creating a new variable, you're just changing that variable. We rarely ever do that. And the reason we rarely ever do that is just because we don't like changing actual data. Instead, we just create a new variable. So the original variable is still there, but now we also have the new variable. So in this example, this is a recode into a new variable. To do this, all you do is you write into, and then you write the new name of the variable. Right? And if you notice at the end of all these things, there's a dot, there's a period. Period means end of command. Okay, so don't forget your periods. And then of course your execute. All right, so next we have the ethnic identity scale, and it's going to be a similar structure. First, we rename the variables, and the reason is that, again, Qualtrics and other survey responses typically don't put things the way we want it to, right? So we have to rename it so that when we access the data set, we know exactly what this is. So in this data set, and don't ask me why, I used EID. The scale was EIS. I don't know why I didn't use EIS 01 and 02 and so on, but I use EID. Whatever. Anyway, so if you turn the page, we rename all the variables. The next step is the EIS, the ethnic identity scale, has about 7 negatively worded items. How do we know this? Well, we went to the actual measure, and we see that there are 7 negatively worded items. Most papers will tell you this, particularly the psychometric paper. And I'll talk a little bit about what the psychometric paper is, okay? But anyway, so we know that we have to reverse code. Ooh, let me scroll down. We know we have to reverse code these 7 items, okay? Now the EIS is on a 4-point scale from strongly, I think it's never or whatever. I don't remember what the scale itself is. So we have to make 1 equal 4. Now, 2 is going to equal to 3, 3 is not going to equal to 2, and 4 is going to equal to 1, right? So basically, one set of numbers gets bigger, as the other set of numbers gets smaller, right? But you need to know the scale. So before you even write this, you need to check either in SPSS or in Qualtrics what the scale was. Is it a 5-point scale, a 7-point scale, a 10-point scale, a 2-point scale? Should be binary, that's not really a scale, but whatever, right? So you need to know that, okay? Because if not, you might do 5-point thinking it's 5-point, but that's going to mess up all your data because there's not going to be any 5s, right? And all your 1s are now 5 when they should have been 4, right? So you need to know the scale. And the next step, you'll do variable label. Now, when I use measures, a measure, which is a series of items, a series of specific questions, can have 1 construct, or it can measure 3 constructs or 10 constructs. It really depends on the measure. So for example, the ethnic identity scale captures 3 constructs: exploration, affirmation, and resolution, right? This measure is composed of 17 items, okay? And one of them is, okay, no, they're out of order, that's why, okay. Now, the CESD, which is a measure of depression, and don't ask me what it stands for because I can never remember, but it is one of the most widely used measures of depression. That measure, it has 20 questions, okay? But only 1 construct, 1 variable, depression. That's it, okay? So when you're doing syntax, you need to know how many variables you're going to have to create, okay? And what items correspond to what variables. And this you get either from me or from the measurement paper, which again, I'll talk about at the end of this, okay? So for the ethnic identity scale, the way I like to do variable labels is if you see item 1, this is the response, right? My feelings about being American are mostly negative. Well, that actually should be about being ethnic racial, but whatever. This is labeled incorrectly. My feelings about being my ethnic racial groups are mostly negative, right? In parentheses here, I put the specific variable that this is measuring, okay? And the reason is I want to see what the question itself was, but then I also want to know in the label what measure it belongs to, or what variable it belongs to. And this makes it a lot easier later on when we are trying to clean data and play around with it. Yeah?
What were the three measures?
In this case, it's so it's one measure, ethnic identity scale, and it has 3 variables within it.
Right.
Exploration, affirmation, and resolution.
Okay.
You'll see them listed later too. So here, we want to be able to specify this. Now, we created a bunch of reverse-coded items. Whenever we do a reverse-coded items, this is under the recode, we just put an R after it so that we know that that item is reverse-coded. You see that? Okay. So now on the bottom, if you go to the end of variable labels, you see FR, that's the reverse-coded, so it lets us know that this item is reverse-coded, just in case we didn't get what the R was, right? And we put the original wording nonetheless. We don't change the wording because the wording is still the wording, right? But you can see here how these measures are reverse-coded. So my feeling, I feel negatively about being American. Well, we're not capturing negativity, we're capturing affirmation, which is supposed to be positive. So we want to change the direction, right? The exploration, I have not participated in any activities that would teach me about the United States. When we're trying to capture exploration, we want to talk about you have done this. So we have to flip it, okay? All right, the next step, this is new. If you go to compute, which starts at the bottom and then goes into the next page. All right, this is how you create average scores. Remember I told you that by getting a bunch of questions and taking the average, you convert ordinal into interval. So we need to do that, right? That's why we have multiple questions that capture the same variable. So again, the 3 variables being affirmation, exploration, and resolution, okay? So in the first command, we are creating the variable for affirmation. FAF, we can call it whatever we want. We can call it Bob if we wanted to, okay? But obviously we want to pick a value, a label that makes sense, that people are going to understand what that means. So in this case, I went with FAF. You could have done EIS-AF, or you could have just done affirm, right? Now, the reason affirm wouldn't work very well in this data set is because we also have affirm for US identity. So you would have 2 affirm variables, and that would just be problematic, right? So you always want to create as specific of a term for this computed variable as possible. And then you just have equal, mean, parentheses, and you list off the variables. Okay? And then close parentheses, period. And then we do the same thing with exploration and the same thing with resolution. If you notice here, if you look at affirmation, you see how all the variables have an R? All the items have an R on top of them? Right? We're computing the average with the reverse-coded items. Right? We don't want to compute it with the actual item because that'll mess it up. Okay? Now, for this scale, every single item that captures affirmation is reverse-coded. That's a big problem. We're addressing that in our own study. We talked about that at the last meeting. Okay, but if you look at exploration, the first item is the only item that's reverse-coded. So when we compute it, we use EID02R, and then all the other EID items. Okay?
Is it a problem if none of them are reverse coded?
It's not a problem at all. Most measures probably should not have reverse-coded items, because whenever you create reverse-coded items, you don't know if you're capturing what you think you're capturing, if you're just capturing a different dimension, which is exactly the problem with this. We will post this on YouTube after we publish our paper, because I just said that. Okay. Variable labels. So now that we've created these variables, well, then we need to make labels for them so we know what they are. So, right, ethnic identity scale hyphen, that's the scale, affirmation. And then in parentheses, we put mean, because we did the mean of this variable. We could have done the sum. We could have done the sum divided by 10. We could have done whatever we wanted, right? So you want to specify in parentheses how you computed this scale, right? And then this last step is for SPSS simplicity. Really, it's actually for M+. M+ is a statistical package that we use later on to analyze a lot of this data, and it doesn't like empty spaces, okay? So because it doesn't like empty spaces, any missing data has to be given a value, okay? Now, when we give missing data a value, we give it a value that would never be seen in the data set. More often than not, I've seen people use two different values, actually three different values. The first is -99, which is the one that I always use. -999, 999, because I guess someone thought that -99 someone might type. And then some people use 999, okay, positive 999. I don't like positive values because a positive value actually could be in a scale, although it's unlikely for it to be that high. But you can see someone maybe in old school days, I can't remember who I was telling this to the other day, but in old days, you would actually have the data in front of you, like the survey, and you would have to type it into SPSS. And this is why we use -99, because when you type it into SPSS, every now and then you might type 9, and the system might get stuck and adds in 3 9s. Okay? Nowadays it's online, so I mean, it doesn't really matter too much, but it's just become a thing of convention. Okay? So there's two commands to this. Okay? In the first command, you are going to recode missing values or empty cells into -99. This is one of the cases where we do not recode into, we just recode. Because we don't need new variables. We just want to say that missing is this. Okay? Now, if you only do this, and then you run analysis in SPSS, SPSS is also going to start giving you a mean of -40. Because SPSS hasn't been told what -99 means. Right? So the second command tells SPSS, hey, by the way, for all of these variables, missing is -99. All right? So then when you analyze correlations, when you analyze means, SPSS will know that -99 means missing. Okay? All right, so that's ethnic identity. I give another example with depression, and it's fairly similar. The only difference is if you go into where the computes are, here we do sums, not means. Okay? And you might be wondering, why? Certain measures are either averaged or summed depending on the protocol for that measure. The CESD, which is a clinical measure of depression and has specific cutoff values, those cutoff values are based on the sum, not the mean. Okay? So for this measure, the sum is meaningful. For something like ethnic identity, most people do the mean. All right? And you might see some people do a combination of the two, and that's perfectly fine. In that case, it doesn't matter. Go with the mean, just because the mean is easier and looks nicer. Okay? But for certain variables, the sum, typically diagnostic variables, so variables that capture alcohol use, that capture depression, anxiety, they typically use sum. Okay? So outside of that is basically the exact same commands that we already use. All right, the last command I want to teach you is under the alcohol scale. Okay? So if you go, actually two commands. The first is value labels. Here. Okay. Now, Qualtrics, when you download the data into SPSS, whatever the value label was that you entered into the Qualtrics response patterns, it automatically imports it into the value label. So typically, you don't have to do much work with that. Okay. But there are some times where you have to fix it. All right. So the example here is the audit. Okay, which is the alcohol use diagnostic inventory or something like that. I don't remember what it actually stands for. But it's one of the most widely used measures for alcohol use, particularly with young adults. Okay, the audit has a specific diagnostic criteria. Okay, and that criteria requires that responses start at 0. Okay, because if they don't start at 0 and you add them all up, then the lowest response you can get is a 10, right? And a 10 is 2 points shy of meeting diagnostic criteria for hazardous alcohol use. That's problematic, right? So in this data set, what we did is we recoded many of the variables, but I only show you this one right here. We recoded it so that 0 is, this is odd, that's not accurate. I think that's the opposite. Ooh, I might have to check this data set.
Oh, this is very hard. I'm so far away. Oh God, my eye. Did I do that right? No, I think the last one. What's the last one say?
3 equals 4.
1, 2, 3, 4. There should be
5.
5 equals 4.
Yeah, I didn't know I did.
Whew. Oh God, that hurt me. All right. So we wanted to make sure that 1 would equal to 0. Okay, so that when we do the diagnostic criteria test, it's set a certain way. Okay. So in this case, you do the recode. We're not going to recode it into a new variable because we want to make sure that the variable is capturing what it's supposed to be capturing. Okay. And then here we had to fix the value labels because the value labels argued that 1 was none because that's how they were entered into the survey system. But that's not the case. 0 is none, right? And this is how you do value labels. So you put the number, and then in the little fake quotations, whatever they're called, you put the label for that number, okay? If you are assigned the demographics section, you want to review the demographics and make sure that they have the appropriate value labels, that they're meaningful, that they make sense. If you want to rename any of those labels, then you would go through the value label command, okay? The value label command can also be useful if you've created a new variable that's categorical. So like for example, sometimes, particularly in our data sets, when it comes to ethnicity and race, we may not have enough Hispanics and Asians in our data set to analyze them by themselves. So what do? Other. And we might create a recoded ethnicity variable where 1 equal, let's say, 1, and those are all the white participants, right? 2, which were all the black participants, still equal 2, because we typically in our college data set, we get a good number of African American black participants. And then 3 equal 3, 4 equal 3, 5 equal 3, 6 equal 3 into what the new variable for ethnicity. And what we did is anyone who was not white or black gets grouped into other, right? Well, then we need to know what 1, 2, and 3 mean. So that's when you would add a value label of whatever the new name of the variable you created, 1, white, 2, black, 3, other. Period, execute. Okay? All right, the other thing I wanted to show you here is recode. There are some measures, and I would typically let you know about this beforehand, okay? But there are some measures that are called gated measures, all right? Gated measures are often used for risky behavior. Alcohol, cigarette, marijuana, risky sex, any behavior that's problematic. I mean, risky sex is problematic, sex itself is not problematic, but you get what I'm saying, okay? And the way that this works is they're called gated questions because if you respond in a certain way on question 1, you don't get any other questions. So for example, if I was working with underage adolescents and I ask them, have you drank alcohol in your life? And they say no, there's no reason why I have to ask them if they drank alcohol last week, right? So we're gonna spare them having to ask the next 50 questions on their alcohol use. I should know. Adolescents start learning this. So, if they suddenly stop using alcohol in the future, it might not be because they stopped using alcohol use, it's just they don't want to do an extended survey. But nonetheless, all right, this is what's called a gated question. So what happens is from a Qualtrics standpoint or a survey sample, they have a response to the first question, but all the responses to all the other questions are empty, okay? Because they never got them, right? Now, for some measures, you might recode them as missing, depending on what people want to do. But for the audit, if they say they've never drank alcohol, if you recode it as missing, then you're not going to be able to calculate a sum for that, right? Not drinking alcohol ever is the equivalent of having said never on every other question, right? So in this case, if they have missing data, if they put 0 on audit 1 on this question, every other question make missing equals 0. Do you see that?
Say it again. Say
Okay.
they answer.
I'll start with the
Okay.
first step too, because the first step is actually important as well.
Alright.
All right, so question 1, have you ever used alcohol in your life? All right. The first step is we have to take care of the people who never answered this question to begin with. So if there's empty, equal that negative 99. That's step 1. Step 2, if you have negative 99 in question 1, do if, that's the command, do if. So essentially what you're saying to SPSS is, if this happens, this is what you're gonna do. So the next thing is, if audit 1 has negative 99, all of these questions missing equal negative 99. And you do this because if they never answered the first question, they would have never had an opportunity to answer all the other questions, right? So those people are actually missing data, okay? But then the next step is, for the people who answered no, they've never drank alcohol, they would not respond, they would not be given any of the other questions, right? They're not missing, they did the question. They just weren't given the question because they've never used alcohol, right? But for us to get a score for that, we need to have something there. Missing is not good enough, okay? So what we're saying here is, if they entered 0, which is none, you have used no alcohol, actually I think it's in the last year for this one, right? Then recode all of these variables such that missing equals 0. Okay, this is probably the hardest command to understand. Recode commands are do ifs commands are really complicated. Okay, you're probably not going to have to do very many of them, if any at all. Okay, I should know there are much more complicated redo commands. Do ifs commands. There was one measure where Rachel and I spent, I think, an hour going through the syntax file, making sure it was accurate. And I think I spent the whole day working on that file, like a year ago, because it was if variable 1 equal 1 and variable 2 equal 2, then new variable equal 3. If variable 1 equals 0 and variable 2 equal 1, then new variable equal 4. And we would have to go through this kind of series of steps because of how the measure was created. Okay? We don't do many of those. So don't worry, you probably won't see this, but I wanted to show you this because sometimes they are required. Okay? Especially when we ask the risk variables. Okay? And then everything after that is the same exact stuff that we've already kind of covered, which is missing value. So you specify what missing value is to SPSS. So SPSS knows that negative 99 is missing. You compute a total score. In this case, it's a sum, because again, the audit has a criteria, diagnostic criteria. You then tell to recode that variable where missing is equal to negative 99, because some people may not have responded to that question, right? You then, okay, so this is a new one. So audit can be analyzed in 2 different ways, and this is something specific to the audit. You can analyze it as an interval data, where you have a quantitative version, right? Where you just take the sum, that's interval, right? Or you can analyze it based on the diagnostic criteria, okay? And that's what this recode audit tote, that's the diagnostic criteria. So in this command, what we're saying is, if 0 through 6, give it a 1. If 7 through 15, that's gonna equal 2. If 16 through 19, that equals 3. And if 20 through 40, that equals 4. If missing, then it has negative 8 there, but it should be negative 9. All right. And then into, and the paper kind of cut it off a little, but it's into audit risk. All right. And then the next line, we want values for what 1, 2, 3, and 4 are. So this is where we give it. So 1 is zone 1, is educational, because they're not really a risk at all. So it's just you want to tell them, hey, alcohol use can be very problematic. Obviously, social drinking is okay, but you can develop risky behaviors, yada, yada, yada. Right? So it's educational. If they're in zone 2, they're at the level where they're getting close to the cutoff value for the audit, for college students at the very least. But they're not at a level where we would be like, oh my God, we need to get these people into treatment right away. So we would give them strong advice about their alcohol use patterns, try to help them get it down. If they're at zone 3 now, they need counseling, okay? This is where you're engaging in problematic alcohol use. And if you're at zone 4, you need to go into a treatment center. you're at the level of extreme alcohol use to the point that you're concerned for like your life and other people's life. And if you look at the questions, it makes perfect sense. If you look at like audit 9, or actually it's like 7, how often during the last year have you had feelings of guilt or remorse after drinking? How often in the last year have you needed a first drink in the morning to get yourself going? There's a blackout question here. How often during the last year have you been unable to remember what happened the night before? Have you or someone else been injured as a result of your drinking? Has a relative or friend or a doctor or another health worker been concerned about your drinking or suggested you cut down? If you're responding affirmatively to these things, you have a drinking problem, right? So of course at that point it's go get help, right? Most college students are not there. They're responding like, yeah, I've drank in the last year, 1 or 3, every now and then when I drink, not like it's minor drinking for most, all right, and that's it. So what you'll do once you get your assignment, because you're all going to have SPSS syntax assignments, is you will open up SPSS, and I'm not going to be able to show it entirely because as you can see, I don't have any options because this computer does not have an active registration. But you'll click new, and then you will write, when you click new, there's 2 options. There's data and there's syntax. So you click new, open syntax. All right, and then the syntax file will open up, and it'll just be a blank canvas. Okay, no worries. It'll be a completely blank canvas, and you'll have to write the code. Okay, and then you can save this just as you would any SPSS file. You just go click File, Save As, name it, save it somewhere. Okay. Things to know. Again, if you see anything in red, there's a problem. You're doing something wrong. You wrote something wrong. Okay, so you want to review that code to see if it looks what you might have done. More often than not is you forgot to put a period, or you put a parenthesis and forgot to close the parentheses. This is something minor, but the syntax really cares about that. Oh, the other thing I forgot to mention, when it comes to value labels, when it comes to these, SPSS does not like contractions. Because the sign for the contraction tells SPSS, we're done. So all contractions, you have to delete the contraction part. So if you see here, I'm trying to find a contraction. I know one of these, I had to go through it and take them all. It might be the depression one. Oh, so see, my friends tried to cheer me up, but I didn't. No contraction. Okay, so if you see an error, it's probably because there's a contraction or a quotation mark. Okay, so you want to be mindful of that. Okay. Oh yeah, so then you'll save those, and then at a certain point, what I'll probably do is I'll set up a meeting and we will run it. Or maybe we'll do it at a lab meeting where I'll put all your syntaxes together and we'll run them all. And then if one has an error message, we can kind of go through and try to figure out why. Okay? And we'll be doing this for, definitely for IRIS, which is a data collection project that we're currently working on. ACERT, which is the collaborative project that I had a meeting about yesterday, and we're going to be figuring out how we're going to do that, because our lab and another lab are going to be co-cleaning this data set, so we have to figure out how we're going to split it, but we'll be working on that one as well. I can't remember if I already did the syntax for Celia. I'm going to have to check, but if we haven't done the syntax for that, we need to do it for that data set as well. And I was talking to Taylor the other day, we have about probably 60 participants, so there's enough there to at least do posters for you two, not necessarily papers. Okay, but it's something. Okay. I should say, Vivian, as well, you can join in on these projects. Because Celia data set is the one with the Hispanic Latinos, so it's building off what we're working on.
Can I tell you something?
Yeah.
I like this more than I like the lit review